Hi everyone. Today's trig lesson, we're going to be learning about coterminal angles. What is a coterminal angle, how to find coterminal angles, and we're going to also learn how to convert between degrees and radians. We've mentioned a little bit about radians before, talking about on the calculator, making sure our calculator was in degrees, but today we're going to look at how to go back and forth between the two measurements. So starting with some definitions. An angle in the coordinate plane is in what's called standard position if its vertex is at the origin and its initial ray is on the positive x-axis. And then angles can actually be measured in two different directions. You can measure angles in the positive direction. Positive, they're drawn counterclockwise. And angles can also be negative. Negative just means you're going to draw it clockwise instead. And then the ray that is not on the positive x-axis is what's called the terminal ray. So just going to practice sketching out some angles really quick. So the first one is a positive angle. So remember, positive angles are measured in the counterclockwise direction. So going this way is counterclockwise. So we're going to have the initial ray on the positive x-axis and the vertex at the origin. So here's our initial ray. And then for 235 degrees, well, we know straight up and down that right angle is a 90-degree angle. A straight angle would be a 180-degree angle. So we've got 90 here, 180 here, 270 would be here. So 235 is going to be in that halfway mark here. So this part of the angle is what's called the terminal ray. So again, we have initial ray, which is on the positive x-axis. Pencil, you have one job. Initial ray. And then you have the terminal ray on that shows the actual angle measure. Okay, so that angle, I usually mark it off starting at the initial ray and curving it around to the terminal ray, just to say that's 235 degrees. Okay, looking at a 120-degree angle, so remember you're going to have the vertex at the origin, the initial ray is on the positive x-axis, and then 120 degrees is a positive angle, so again that's going to be measured in the counterclockwise direction. 90 degrees would be that right angle, so we just want to go 30 more than that 90 degrees. I did not bring a protractor, so I'm just going to freehand it approximately here. So we would mark off that angle showing that we started at the initial ray, we went to that terminal ray, and we went 120 degrees. Notice the next one is actually a negative angle. Remember, negative angles are measured in the clockwise direction, clockwise instead. Okay, we're still going to have the initial ray on the positive x-axis. We're still going to have the vertex at the origin. Okay, but instead of going counterclockwise 60 degrees, we're actually going to go clockwise, which looks like you're kind of going downward 60 degrees. So if I went down 60 degrees, it would be about 2/3 of the way to just that y-axis, approximately here. Again, did not bring a protractor. And then you're just going to mark it off, showing that you went in the clockwise direction for that negative 60-degree angle. Looking at 390, 390 is more than all the way around a circle. Because if you go all the way around a circle, that's 360 degrees. You'll probably remember that from geometry last year. So 390 goes all the way around and a little bit more. We're still going to have the vertex at the origin. We're still going to have the initial ray on the positive x-axis. But now, if it's positive, again, you are still going to go in the counterclockwise direction. But you're going to go more than all the way around. So basically, we go all the way around is 360. And then 30 more degrees would be that 390. It kind of looks like a 30-degree angle, except it went all the way around. This angle brings us into our next topic. Our next topic, we're going to talk about coterminal angles. Coterminal angles have the same vertex and the same initial and terminal rays. The angle that we just found here, that 390 degrees, that is actually coterminal to a 30-degree angle. If you were to draw a 30-degree angle here, it would have the same initial ray and the same terminal ray. Let me see if I can draw it on top. So a 30-degree angle would have the same initial ray, the same terminal ray. It would just be 30 degrees here. To find a coterminal angle in degrees, you're going to either add or subtract multiples of 360. Add or subtract 360. And you can actually do it. The reason I said multiples of 360 is because there's numerous, infinite amount of coterminal angles. You can add 360 again and again and again and again and again until you find every single one. But usually I just ask you to find one positive, one negative, or even just one positive. So on the first one, I'm actually going to sketch out the first one so you can kind of visualize the coterminal angle. I'm going to start by just sketching a negative 80-degree angle, which means it would be, looks like it goes downwards because that's clockwise. It has its vertex at the origin. It has its initial ray on the positive x-axis. And then its terminal ray we're going to draw by going clockwise 80 degrees, which is very close to a negative 90-degree angle. So about right here, maybe even a little closer. I'm going to mark this off that this is a negative 80-degree angle. And then a coterminal angle, again, you can find by adding or subtracting 360 degrees to this angle. So if I were to add 360 to negative 80, I would get a, did I type that right? Yes, I did type it right. Okay, I would get a 280-degree angle. So if we were to mark that off, 280 degrees. 280 degrees, again, it would still start with its initial ray on the positive x-axis, its vertex at the origin, but because it's positive, you wouldn't actually be going counter, or you wouldn't actually be going clockwise, you would be going counterclockwise. So if I went counterclockwise, 280 degrees, so 270 would be all the way around here, and then 280 would be a little bit more. So all the way around here would be your 280-degree angle. That. So these are coterminal to each other. Again, coterminal angles have the same initial ray, same terminal ray. It's just sometimes they're measured in the negative direction, sometimes they're measured in the positive direction. Like this one, sometimes one went all the way around and a little bit more. So if we practice finding some more coterminal angles, again, you can add or subtract to find a coterminal angle. For the next one, I'm going to subtract. So if I subtract 360 degrees from 135, 360 from 135, I get a negative 225-degree angle. And again, this is just one of the coterminal angles. There are an infinite amount of coterminal angles. Similar for the next one. For the next one, it's a 222-degree angle. For that one, I'm actually going to add 360 just so we see it in the other direction as well. The next one would be a 582-degree angle, would be coterminal to 220 degrees. Excuse me, 222 degrees. That's 528. We want 582. And then lastly, finding an angle that's coterminal to 500 degrees. I'm gonna, on this one, let's see, I'll probably subtract on this one, minus 360, which would give me 140 degrees would be coterminal to 500 degrees. Coterminal in degrees is pretty easy. We will learn about radian measure on the back, and we'll also look at how to find a coterminal angle measured in radians as well. So looking at the next question, it comes from an old AP test. I'm just going to annotate it real quick. Which of the following angles in standard position, again, standard position just means its vertex is at the origin and its initial ray is on the positive x-axis. Which angle in standard position is coterminal with an angle measure of 150 degrees in standard position. So looking through these, first off, if you want to, you can actually try and just maybe find a coterminal angle with 150 degrees. I'm actually just going to do a quick little calculation, and I'm going to add 360 and then also subtract 360 just to find a couple of them. So if I add 360, I get 510, and then I'm also going to subtract 360 and find, just so I find one positive, one negative. So 510 is coterminal, and negative 210 is also coterminal. So looking through the answer questions, I do see one of the answers that I just found. Okay, 30 is not right. 210 is not right. If it said negative 210, that would be a maybe, but it didn't. Angle measure of 570 is not right. 570 wouldn't even be coterminal with this one because that would only be 60 degrees more than here. And then just going to check and make sure that the reasoning here is correct. The angle measure of 510 is coterminal because 510 minus the angle we just found is 360. And that would basically be just checking this answer. To find the coterminal angle to 510, you would subtract 360 and you get 150. So C is correct on this one. On the back side, learning about radians for the first time. Just like there's different units of measure to measure length, like you can measure in feet and meters and all these other different ones, there's also different ways, different units to measure angles. The one you're probably used to is a degree. A degree is an arc that is 1/360th of the circumference. That's why all the way around a circle is 360 degrees. But a radian is an angle whose arc length is equal to the radius of a circle. And its arc measures 1/2 pi of the circumference. So in degrees, if there's 360 degrees all around the circumference, then that means in radians, it's 2 pi all the way around the circumference. So I'm just going to draw a quick little diagram. Okay, so we know we have 0 degrees, and then if we went all the way around, that would be 360 degrees. Okay, we just said that all the way around in radians would be 2 pi. Okay. So looking at information then, let's mark off some other degree measures. So I also know that my 90-degree angle is that right angle here. A straight angle would be 180 degrees. 2/3 all the way around would be 270 degrees. Okay, so then how many degrees would be in 1 pi? Well, if all the way around a circle is 2 pi, well then halfway around the circle would be 1 pi. And usually we don't say 1 pi, usually we just say pi. So to answer the question, how many degrees are in 1 radian? 180 degrees, or excuse me, how many degrees are in 1 pi radian? 180 degrees are in 1 pi radian. 180 degrees. Okay, well then how many radians are in 90 degrees? And then here's where we have to get into a little bit of fractions. So halfway around a circle was 1 pi. So then 1/4 of the way around the circle would be this amount divided by 2. So instead of saying 1/2 pi, usually we say pi over 2. But it is the same, honestly, it's just 1/2 of pi. So then if we went 2/3 of the way, or 3/4 of the way, 1/4, 2/4, 3/4 of the way around the circle, we would have, this is 1 pi over 2. This is 2 pi over 2, which would just simplify to 1 pi. So then this one would be 3 pi over 2, which a lot of people think about as 1.5 pi, but we write it as 3 pi over 2. So the answer to the second question, how many radians are in 90 degrees? Pi over 2 radians are in 90 degrees. All right, for converting between, usually I do need a little calculator to do some of the conversions, not because the multiplication is difficult, it's just time consuming. So going in both directions, where did I put my highlighter? We've got degrees to radians and then radians to degrees, depending on which one you're asked for. To convert from degrees to radians, we're going to take the degrees amount, degrees, and we're going to multiply by pi over 180. And then if we're going the other direction, if we're doing radians to degrees, we're going to take the radians amount, and we're going to multiply by 180 over pi. Okay, looking at the first one just says to change this whole column, change the degrees to radians. Okay, so to change my degrees to radians, again, we're going to multiply by pi over 180. So we're going to multiply by pi over 180. I actually like to do a little bit of simplifying before I multiply, just to get that little brain workout. Remember, you can simplify diagonally. When I look at both of these, they actually both divide by, I believe, 20 divides into both. Okay, so if we're going diagonal, 80 divided by 20, let me put a 1 under this to give me two fractions. If I divide 80 by 20, I get a 4. If I divide 180 by 20, I get a 9. And then from there, I'm just going to multiply these like two regular fractions. Top times top would be 4 pi. Bottom times bottom would be 9. And there's my answer in radians, 4 pi over 9 radians. For the second one we have 120 degrees that we're converting to radians. Okay, again, I'm going to multiply by pi over 180 times pi over 180. I'm going to put the 120 over 1 just to make it a fraction, and then I'm going to look diagonally and see if anything will reduce. And it does. Both 120 and 180 divide by 60. 120 divided by 60 is 2. 180 divided by 60 is 3. And then you get some super easy multiplication now. Top times top would give me 2 pi. Bottom times bottom would give me 3. And then we'll just label that answer as radians. If you don't simplify first, you will have to reduce the fraction after the fact, which is totally fine. Okay, and then one more at the bottom, 22 degrees that we are converting to radians. Again, we're going to multiply by pi over 180. I'm going to take that 22, pop it over a 1. Now looking diagonally for anything that simplifies, I notice that both 22 and 180 are even, so they can at least divide by 2. If I divide 22 by 2, I get 11. 180 divided by 2 is 90. And then multiplying my top times top would be 11 pi. Bottom times bottom would be 90. This is not as pretty of a fraction, but still an answer that is in radians. All right, going the other direction now. The other direction, we have the radians already, and we want to change it to degrees. So we have to multiply by 180 over pi. And I know you're probably thinking, how am I supposed to ever remember which one is which one? How I remember is because we need to multiply, or because this pi needs to cancel to get it in degrees, I know that that pi is going to end up needing to be on the bottom to cancel diagonally. Other than that, I don't have a better way. I just know that I need to cancel my pi, so I need it to be diagonal, hence why it's on the bottom. So when I look at this now, obviously your pi's will cancel. Okay, remember, you can reduce beforehand, you can reduce after. It's kind of up to you. If I multiply now, top times top would just be 180. Bottom times bottom would be 6, and that actually divides perfectly to give you a 30-degree angle. For the second one, okay, we've got 11 pi over 20. Remember, we're trying to get it to be in degrees, so I need this pi to cancel. So we're going to multiply with the pi on the bottom and the 180 on the top. And now when we look diagonally, that pi will cancel. Again, you can simplify beforehand. You can also simplify after. It really doesn't matter. If we simplify beforehand, both 20 and 180, you can divide by 20. 20 divided by 20 is 1. 180 divided by 20 would be, what is that, 9? And then we're not left with a whole lot to multiply. On the top, we have 11 times 9, which is 99. And then on the bottom, we just have a 1. So our final answer is this is 99 degrees. And then one last angle that we're converting. Again, if we're trying to get it to turn into degrees, we need that pi to cancel, which means we're going to multiply by the fraction that has the pi on the bottom and then the 180 on the top. Those pi's are now diagonal, which means they'll cancel out. And then again, you're welcome to simplify beforehand, simplify after. It's kind of up to you. Let's see. If I simplify beforehand, both the 180 and the 4 are divisible by 4. If I divide 4 by 4, I get a 1. If I divide 180 by that same 4, I get a 45. And then that only leaves me with a 5 times 45 left. On the bottom, we would just have 1 times 1. So on the top, 5 times 45 is 225, and that is my angle. All right, next one, we have a little word problem, so I'm going to grab my highlighter so I can annotate real quick. It says, what is the length of the arc of a circle with a radius of 12 centimeters and a central angle of 3 pi over 8 radians? And we are asked to leave our answer in terms of pi, which again just means don't grab your calculator and type in 3.14. This actually uses one of the formulas that we had yesterday. Okay, yesterday we had an arc length formula that was, I'll write down the one from yesterday and then we'll adjust it. So we had arc length equals our central angle out of 360 times, if this is arc length, remember you're going to multiply it by the circumference formula. If it was sector area, you would multiply by the area of a circle formula. So for arc length, we'll have 2 pi r. 2 pi r. Now, we kind of have a choice now. One of the things we could do, we could take this central angle and convert it to degrees so that we could use our degrees here. But honestly, I feel like it's easier if you just swap out this 360. So if our central angle is in radians, we need this formula to be in radians as well. And if you remember, we talked about it earlier. In radians, 360 degrees is just 2 pi. So instead of having theta out of 360, we're going to do theta out of 2 pi for radians. And then I'm going to substitute in what I know. Okay, so I'll have arc length equals my central angle, which is 3 pi over 8, divided by 2 pi, because we're doing a fraction out of the whole entire circle, times 2 pi r. 2 pi times my radius of 12. Okay. I'm going to do a little adjusting right here where we have, you see how we have like a fraction divided by 2 pi. You can actually change that to be multiplying by the reciprocal. So instead of dividing by 2 pi, you can multiply by the reciprocal of 2 pi, which would be 1 over 2 pi. And then I'm going to also bring down this right here, 2 pi times 12. Now remember, yes, you can multiply all at once and then simplify later, but you can also multiply, or excuse me, simplify before you do any multiplying. So I have some things that I see can cross out. The 2 pi's are diagonal from each other and can cross out. Let's see, other direction, I don't have any more pi's to cancel with this, but I can reduce maybe the 8 and the 12 beforehand. Both of these you can divide by 4. If I divide 8 by 4, I'll get a 2. If I divide 12 by 4, I'll get a 3. And now that does not leave us with a whole lot to multiply. If we look at all the tops, we have 3 pi times 1 times 3. Top times top times top would be 9 pi. On the bottom, we just have 2 times nothing times 1, which is just 2. So my final answer for the arc length is 9 pi over 2. We're leaving it in terms of pi, so you can leave it just like that, but we do need to label this, and since this was a measure of length, we're going to call that centimeters. It was not area, so it's not centimeters squared, it is just centimeters for that arc length. All right, and then one last question. Name an angle in radians that is coterminal to 5 pi over 6. So just to remind you, coterminal angles have the same vertex and same initial and terminal rays, and when they were in degrees, we would add or subtract 360. But if we need to name an angle in radians, we don't want to add or subtract 360. We want to add or subtract the equivalent of 360, but in radians. So we go, remember, the equivalent to 360 degrees in radians is 2 pi. So we want to add or subtract 2 pi. Add or subtract 2 pi. So from this, should we do, let's do both. Let's do both. Let's add 2 pi and subtract 2 pi. 5 pi over 6. So we end up with 1 positive and 1 negative. Okay. So I want to add 2 pi to one and subtract 2 pi from the other, plus 2 pi minus 2 pi. Okay, now remember, to subtract a quantity from a fraction, you will need to get a common denominator. So I'm going to start by just rewriting both of these so that they have the same denominator as this one. So for the first one, if I put a 6 on the denominator, I'm going to also need to multiply the top by 6. So that would switch to 5 pi over 6 plus 12 pi over 6. 5 pi over 6 plus 2 pi times 6 would become 12 pi over 6. And now they have the same denominator. And remember, when you add fractions, you only add the numerators. The denominator will stay the same. So if I add 5 pi and 12 pi, I'm going to add the coefficients just like you would normally add a variable. That would become 17 pi over 6 would be coterminal to 5 pi over 6. And then practicing finding one that's negative, 5 pi over 6 minus 2 pi. Again, just like the last one, I want to get the same denominator, so I'm going to multiply the bottom by 6 and the top by 6. That's going to give me 5 pi over 6 minus 12 pi over 6. Okay, again, you only add or subtract the numerators on fractions. The denominator will stay the same. So 5 pi minus 12 pi, only subtracting those coefficients, pretending almost like the pi is a variable, would give you negative 7 pi over 6. All right, guys, thanks for learning with me today.